Introduction to i.MX27 Multimedia Application Processors, Freescale. Welcome to this training module on Freescale's Introduction to i.MX27 Multimedia Application Processors. This training module provides an overview of i.MX27 Multimedia Applications Processors, its key modules, and applications. The i.MX27 Multimedia Applications Processors are based on the ARM 926 EJ-S microprocessor core, which runs at 400 MHz, has MPEG-4 H.263 and H.264 D1 hardware codec, and high-speed CMOS sensor interface. The i.MX27 processors provide the performance with low power consumption required by modern digital devices like feature-rich cellular phones, portable media players, and mobile gaming machines, personal digital assistants, and wireless PDAs, portable DVD players, and digital cameras. The MX27L processors are targeted for video and voice-over IP and smart remote controllers. It also provides low-power solutions for any high-performance and demanding multimedia and graphics applications. The i.MX27 incorporates Freescale's platform-independent security architecture, a combination of security features that provides a high level of confidence for carriers, content providers, and consumers. The i.MX27 supports connectivity to a wide range of external devices, cameras, displays, and more. The i.MX27 supports 10 and 100 megabit per second Ethernet 802.3 networks, thus introducing Ethernet connectivity to the i.MX family. The i.MX27 also connects to hard disk drives through its ATA6 compliant interface for large storage capacity devices to enhance media on the go. Its external memory interface supports SD-RAM, DD-RAM, NAND flash, and PSRAM. The i.MX27 is built using Freescale's Smart Speed technology. The dynamic process temperature compensation mechanism measures reference circuits delays dependent on process speed and temperature. The dynamic processor temperature compensation then lowers the voltage to the minimum level needed to support the current operating frequency. The i.MX27 has a built-in, low-power eMMA2 hardware block, which consists of an MPEG-4 and H.263 and H.264 encoder and decoder for D1 resolution and image pre-processing and post-processing stages. These features provide superb image and video quality. Devices with the i.MX27 are capable of long video playback time with exceptional video quality. It also provides lower power solutions for any high-performance and demanding multimedia graphics applications. To address the continuing need to reduce power consumption, Freescale incorporated the following techniques into the i.MX27 processor. Clock distribution circuits and digital ICs with the complexity of the i.MX27 applications processor can consume as much as 40% of the total dissipated power. By inserting gating into the clock paths, unused portions of the chip can be disabled. Well biasing is a feature incorporated in the design used to reduce the sub-threshold channel leakage. For the 90 nanometer digital process, the sub-threshold leakage could be reduced by a factor of 10 over the nominal leakage. The diagram shows all the blocks presented in i.MX27 video processor. It has connectivity blocks, which has ATA, SPI, and UART, memory expansion blocks, which supports MMC SD cards, MEMSTICK, and PCMCIA, multimedia accelerator block, system control blocks such as JTAG, bootstrap, and clock management, standard system I/O block, human interface block like an LCD Control Smart LCD, and an 8x8 keypad, and multimedia interface blocks. The diagram describes how the modules within the i.MX27 processor interface with each other and provides a high-level overview on how the architecture of the buses are configured and multiplexed. The ARM926 EJ-S, or the ARM926, is a member of the ARM9 family of general-purpose microprocessors targeted at multitasking applications. The processor is intended to operate at a maximum frequency of 400 MHz in order to support the required multimedia use cases. Furthermore, an enhanced multimedia accelerator and LCD controller are included in the application processor domain to offload from the core functions such as color space conversion, image rotation and scaling, graphics overlay, and pre- and post-processing. The ARM926 supports the 32-bit ARM and 16-bit thumb instruction sets. The ARM29 includes features for efficient execution of Java bytecodes. A JTAG port is provided to support the ARM debug architecture along with associated signals to support the ETM9 real-time trace module. The ARM926 EJ-S is a Harvard cached architecture including an ARM 9EJ-S integer core, a memory management unit, separate instruction and data AMBA AHB interfaces, separate instruction and data caches, and separate instruction and data tightly coupled memory interfaces. The ARM926 EJ-S interrupt controller is a 32-bit peripheral that collects interrupt requests from up to 64 sources and provides an interface to the ARM926 EJ-S core. The ARM interrupt controller includes software-controlled priority levels for normal interrupts. To address the need for secure wireless communication, the i.MX27 processor provides confidentiality, authentication, integrity, and legitimacy within its architecture. The modules, the Secure Controller, Sahara 2, Runtime Integrity Checker, and the IC Identification Module are built-in features to support a broad range of security-enabled products. For carriers, the security architecture provides protection features to help guard against malicious service attacks, theft of services, configuration protection, and concerns with cloning. For content providers, it helps block illegal access to licensed content, thereby protecting against unauthorized use and distribution. And for consumers, private data is designed to be inaccessible, helping protect against identity theft. The CRM generates clock and reset signals used throughout the i.MX27 and MX27L processors and also for extended peripherals. The i.MX27 and MX27L processors consist of three major sets for power supply voltage named QVD, that's for the core logic supply, Fuse DVD, that's for the analog supply for the fuse box, and NVDD and VDDA for I/O supply. The external voltage regulators and power-on devices must provide the applications processors with specific sequence of power and resets to ensure proper operation. The i.MX27 processor comes with an enhanced multimedia accelerator Lite, the EMMA_IT, which comprises independent pre-processing and post-processing stages that provide exceptional image and video quality. The eMMA_IT represent a major breakthrough to solve the problem of high MIPS required for video encode and decode operations in mobile and wireless applications. Tight integration and memory pipelining coupled with AHB master bus mode operation ensure minimal system loading. To further offload the CPU, live video stream data enters the eMMA_IT module directly through an internal private data interface. The digital audio multiplexer, the AUDMUX, provides a programmable interconnect fabric for voice, audio, and synchronous data routed between the i.MX27 processor's SSI modules and external SSI, audio, and voice codecs. The AUDMUX is designed so that resource configurations do not need to be hardwired, but instead can be shared in memory-different configurations. The AUDMUX interconnections allow multiple simultaneous separate audio, voice, data flows between the ports in a point-to-point or point-to-multipoint configuration. The CMOS sensor interface is a logic interface that enables the i.MX27 and MX27L processors to connect directly to external CMOS sensors and CCIR656 video sources. The sensor port provides a connection to either one or two image sensors, of which only one sensor can be active at any given time. The sensor port supports a direct parallel interface to either CMOS or CCD sensor controllers using a parallel interface with widths of 12 bits, 10 bits, 8 bits, or 8 bits at data bus rates of up to 60 MHz. The sensor port may be configured to perform outputs of a still image to non-contiguous memory buffer, enabling efficient memory use under an open OS. The video codec module in the i.MX27 device supports full duplex video codec processing and multi-party calls. It integrates multiple video processing standard together, including H.264BP, MPEG-4SP, and H.263P3. The video codec uses two bus interface protocols, the IP bus for register access control and the AHB bus for data throughput. The video codec module uses three memory components: embedded memory, system internal memory, and system external memory. Embedded memories include dual port register files, single port register file, dual port SRAM, and single port SRAM. System internal memory is used by motion estimation to increase codec performance. System external memory is used to store input-output image pixel data and bitstream data. The fast Ethernet controller is designed to support both 10 and 100 megabit per second Ethernet standard 802.3 networks. An external transceiver interface and transceiver function are required to complete the interface to the media. The fast Ethernet controller supports the 10/100 megabits per second M2 and 10 megahertz only 7-wire interface, which uses a subset of the M2 pins for connection to an external Ethernet transceiver. The fast Ethernet controller supports three different standard MAC-PHY interfaces for connection to an external Ethernet transceiver. The Direct Memory Access Controller provides 16 channels to support linear memory, 2D memory, FIFO, and end-of-burst enable FIFO buffers to support a wide variety of DMA operations. Initiation of a DMA cycle can be done through software control or by DMA request assertion. The diagram shows a simple V2IP device requiring a minimum number of chips. When used in a typical V2IP device, the i.MX27 processor delivers the power to drive high-quality audio through wideband audio and wideband acoustic echo cancelers, in-call audio, and video recording on flash or other removable media, and decentralized three-way audio-video calls. It also has the potential to provide the ability to make V2IP calls with Bluetooth audio. This slide shows a block diagram of an IP camera where the i.MX27 has been used interfaced to CMOS sensor SoC, codec with speaker driver, USB high-speed transceiver, STIO module, and an external SD card.